So let's begin with create our model, and we just make a new folder in here as a hub location problem and store and save all the data here. So first of all, we just want to create our model. In this regard, we define a function as a create model. So let's begin with edit, and we just name as a create model. And we consider 40 customers, n would be equal to 40, and m would be equal to 20. And add some comment here as a number of customers and number of service center. So let's define the position of the customers and service centers, and I think that's better that we just generated the position of customers here and then copy it in our file. So let's consider that all customers will be given between 1 and 99. So we have a XC and YC for customers and XS and YS for service centers. So we just generate it randomly. And we usually just run the I with between 1 and 99 with the size of n, that would be 40. So this is our XC, and I just put it as in mat to str function to make a matrix. So copy it into our model and use same procedure for YC. So it will be happen for XS and YS. It's just bear in mind that number of service center would be 20. So XX would be 20. This is for XS and this is for YS. We just put it in a master function to define our matrix. It would be more reasonable. So just put some comment here. Please bear in mind that this is a position that not used in GA. This is just geographical position, and we just wanted to use measure distance. So for customers, we have a demand. So just define it as a D, and D would be, I think that it's a better idea to give a number between 5 to 50. So D would be something like that, just generated as we generated for a position of customers and service center. and also put the comment here. So just save it as a worker rate model. We have also distance between the customers and service centers, so we just define D, that zeros would be N and M with size N and M. This is number of customers and number of services. I think it's better idea to define D and M automatically. So we just copy it here. So I think that this code is just give us a number of N and M that would be connected to customers and services that would be generated automatically. And we delete this part. So we just, I already told you that we want to just use city block distance and norm 1. So for I equal to 1 to n, and for j which is equal 1 to n, we want to create a measurement, and this is measuring the distance between each of customers and service centers. So we use this code. Since we just want to city blocks distance, so we put 1 as norm 1. Just save it. And add some comments here. So we just want to define another parameters that related to the customers, just related to the service centers. So this is the cost for opening any service center, and I think that before that we have to consider some points. So as I told you that we have to estimate the cost for opening service center. We cannot define randomly because it may affect our cost functions, and it may give us some solution that may be unrealistic. So we have to estimate cost with respect to the parameters that we have. We just wanted to use the following procedures. So just bear in mind that we have to at first measure the maximum distance for a given plane. So we just generated randomly between 1 and 99. So I think that this is a maximum distance that would be measured by this formula. This is a Euclidean distance, and it is SQRT 100 power 2 plus 100 power 2. And then we just compute the average of this value, because we cannot consider the maximum distance. The average value would be sensible in this regard, so we just divide it to 2, and then since we have a maximum demand which will equal to 50, we just multiply to the 50 and the C would be obtained, and then for all customers we compute this value for all customers. So C would be multiplied to 40. 40 is all customers, and for any service center I think that we can just divide this value to 20 to the number of service center. This is a straightforward procedure to estimate cost for opening service center, and I think that it will be better idea to consider the higher cost for this value. So let's just crunch some numbers in our software. We have a maximum distance with this formula, SURT 99 power 2 plus 99 power 2. So it's around 140, and we just divide it to 2, and we want to compute the average distance. So it's 70, and then and we have to multiply it to maximum demand. So the maximum cost for each customer would be this value. So for all customers, we can just multiply it to number of customers, and then we just divide it to number of service centers. So this value 7,000 would be a good estimation of the cost for opening any service center. So we just consider the higher value than this. For example, C would be rand I between 8,000 and 12,000. I think this would be a good idea. So we have defined many different parameters here. We just connected and saved in our model. So our model is created. Let's just run it. So this is our model: XC, YC, XS, YC, D, which is distance between customers and service center, D, demand for the customers, and C, which is the opening cost for the service centers. We can also plot these values. So sorry, we just have some mistake here, because we have to use model before that. So this is a position for our customers, and hold on. Position for the service center. So the red score is just position for the service center, and black circle is just position for the customers. And I think that is enough. We just create our model and save it in here, and we can access through our metaheuristics algorithm by just calling this function.